All right, so we're going to look at questions 11 through 15 on our semester exam review in this video, and this section has a lot of calculator questions. In fact, even though this first one isn't labeled calculator, I'm pretty sure I actually did pull it from a calculator section, but it doesn't require a calculator. In fact, there's nothing to do with a calculator on this question. So 11 gives us a graph. It says the graph of the differentiable function f is shown in the figure above. Which of the following is true? And then all of our answers have something to do with the derivative f prime at these three different points that are on the graph. So I know that f prime is the slope of the line tangent to the curve. F prime is the rate of change at one point. So I'm just going to come over here and I'm going to kind of like draw in my tiny little slopes, right? There's the slope at -2. This is the slope at 0. This would be the slope at 3. Those are our tangent lines. Well, now I got to figure out which of these is bigger, which of these is smaller. So at this point, at 0, my slope is 0. I have a horizontal line, so my slope is 0. At -2, my slope is positive, so whatever my derivative is has to be positive at that point. And at 3, that slope is negative, so whatever my derivative is has to be negative. So then if I were to put these in order from greatest to least, I would go negative, 0, positive. So f prime of 3 is less than f prime of 0, which is less than f prime of 2, right? Negative, 0, positive. So then I just have to pick that answer. So f prime of 3 less than f prime of 0 less than f prime of -2. That's D. Number 12 gives us the function f has a first derivative given by f prime of x equals x to the fourth minus 6x squared minus 8x minus 3. On what intervals is the graph of f concave up? So concavity is typically done with the second derivative. You can use the first derivative, you can look at where's the first derivative increasing and decreasing to figure out concavity, but to me it's easier to use the second derivative as much as possible. So in this case, I'm going to start by taking the second derivative, and I can do that pretty easily for this one. This is a really easy derivative. It would be 4x cubed minus 12x minus 8. And then I want to know where is it concave up, which means I want to know where is this positive. Well, because this is a calculator question, I don't have to solve this equation and do intervals. I can go look at my graph and just look at where's the graph above the x-axis, where is it positive. So I need to go and graph my second derivative, 4x cubed minus 12x minus 8. So I'm going to go to my calculator. This is different from the calculators we have in class. This is more like a TI-84, but it's what I have. So 4x cubed minus 12x minus 8. I'm going to graph that, and I want to see where is this graph positive. Well, I can see that this graph is only positive for the very end. So I'm going to try and find that point. Okay, and in this case, that point is at 2, okay? It crosses the x-axis at 2, so at 2 to infinity, our graph is positive, and since the second derivative is positive, that means it would be concave up. So 2 to infinity is where we would be concave up. Okay, the next one, the function g is continuous on the closed interval 1, 4, with g of 1 equals 5 and g of 4 equals 8. Of the following conditions, which would guarantee that there is a number c in the open interval where g prime of c equals 1? So this question feels like a lot when you try and read it, and it can seem really hard. This is why it's important to know your definitions and your theorems. So in Unit 4, we talked about something called the mean value theorem. And the mean value theorem says that the derivative is equal to f of b minus f of a over b minus a. The instantaneous rate of change is equal to the average rate of change. And that's the phrasing that this is using, which would guarantee that there is a number c in the interval such that g prime of c equals 1. Well, if I take these numbers that I was given at the beginning, so g of 4 minus g of 1 over 4 minus 1. G of 4 is 8, g of 1 is 5, 4 minus 1, 8 minus 5 is 3, 3 over 3 gives me 1. So that the average rate of change is equal to 1. So what this is asking is, which statement guarantees that at some point the derivative has to equal the average rate of change? So really what this question is asking is, What has to be true for us to be able to use the mean value theorem? What is the condition required for the mean value theorem? So the mean value theorem started by saying, let f be a continuous and differentiable function. That's how we start the mean value theorem. So to use that theorem to be able to prove that at some point our derivative has to equal our average rate of change, we need the function to be continuous and differentiable. Well, it tells us that it's continuous, but it does not tell us that it is differentiable. To be able to use that theorem, it has to be differentiable. So B would be our answer. All right, the next one gives us a bunch of second derivatives, and it asks which of the following are graphs with exactly 2 points of inflection. So a point of inflection is where your graph changes concavity. Is where it changes from concave up to concave down or concave down to concave up. That's a point of inflection. So what that means, if we're dealing with the second derivative, is where does our second derivative change signs, right? Because the sign of the second derivative, negative or positive, tells you the concavity. Negative second derivative, concave down. Positive second derivative, concave up. If we switch from negative to positive or positive to negative, we are switching concavity. So we need to figure out which of these equations switches from positive to negative or negative to positive exactly 2 times. And if we're talking about a graph and we're talking about switching from positive to negative, we're talking about an x-intercept. So we're really looking for which of these equations has exactly 2 x-intercepts. So we need to graph these. So first one is x times x minus 1 squared times x plus 2 squared. So I'm going to come over to my graph, and I'm going to do x times x minus 1 squared times x minus 2. Was it also squared or was it cubed? It was cubed. Oh, and it's plus 2. So x plus 2 and then cubed. I'm going to graph that, and I'm going to look and see how many x-intercepts this has. And really, not just x-intercepts. How many x-intercepts does it have where it changes sign? So we have an x-intercept where it changes sign over here on the left side. Okay, at about -2, our graph changes from positive to negative. So that means f would change from concave up to concave down. So that would be a point of inflection. And then at 0, our graph also changes concavity because it crosses the x-axis. We have a third x-intercept over here at 1 is what it looks like, but this would not be a point of inflection because our graph does not change sign. It's still positive on either side of that, so that would not be a point of inflection. So this one only has 2 points of inflection. So F is one of our answers, so I can go ahead and get rid of A and B. So now, looking at my answer choices, apparently G is for sure going to have 2 points of inflection, just based on the fact that it's in both answers. So all I need to worry about checking is H. So I need to go and graph H, and I notice that the only difference between F and H is the -1 at the end. So that's all I'm going to change in my equation, is I'm going to stick a -1 at the end. And then I'm going to come back to my graph, and I'm going to look again and see how many times does my line cross the x-axis. So there's 1, 2, 3, and 4 different times that it crosses through the x-axis. So H has 4 points of inflection, not 2. So answer is C. All right, and then the last one for this video, we have y equals x squared times e to the x minus 1, and we want to find dy dx, which means we need to take our derivative. Well, looking at this function, we have x squared times e to the x minus 1, which means that this is going to be product rule. So we need to do first times the derivative of the second. So the derivative for e to the x minus 1 would be e to the x. Plus second, so e to the x minus 1, times the derivative of the first. So derivative of x squared is 2x. Now, the way this is written is not an answer choice. So we need to simplify this. So I'm going to distribute my multiplication. So we would have x squared e to the x at the beginning. And then we would have 2x times e to the x. And then 2x times -1 would be -2x. And so then this matches with answer choice C. All right, so that was the next set.